Hey guys, so we've got another dreary wet Auckland winter weekend happening, and lucky for me this week I received another package in the mail. So this one comes from a gentleman named Andreas, and this was shipped all the way from Austria. So thank you very much, Andreas, appreciate this. So without too much fanfare, what he has sent me is a whole bunch of diabetic test strips. Hence the latex gloves at this point. Usually I'm not too worried about handling stuff at this point, but they are essentially medical waste, even though he has assured me that there is no particular risk associated with touching his blood. It's diabetes is not contagious or anything like that. But you know, just for safety's sake, he's also got a little card here. So sample, plastic coating peeled off, and if we compare that to a normal one, so you can see what he's talking about. They normally come with this plastic coating here, and he's peeled them off to show that essentially the whole inside conductive strip or circuit part is looks to be gold plated, which is very nice. Well, those are taped over, so I assume the other side appears to just be a flat bit of white plastic like that. So yeah, very interesting. I think now I've peeled one of these in the past, and one of the pains with peeling them, so if I peel that off in the same manner that he's done, is, as you can see there, the adhesive stays basically covering up the gold. It stays on the wrong side, which is kind of annoying. If it wasn't for that, you would probably be able, these would probably be pretty trivial to process, but the problem with having the adhesive on this side is that it's unlikely that the acids would be able to contact the gold, so they'll require some further processing. I'm not quite sure how many is sent. I'll have a look at that in a moment. And I think what we'll also do with these is, because we've got some obviously some plated contacts there, we'll have a quick look under the microscope, apply a little drop of 50% diluted nitric acid, which ends up being about 35% nitric acid, and just try and gauge how thick the gold plating on the contacts are. And yeah, what I'll also do is I'll clean off some of the adhesive and just see if it's the same thickness all the way through, because they might be selectively plated up on this side. And yeah, and then we'll just basically work out a process for these and figure out what the yield per test strip is. So I'll quickly get everything set up and be back in a moment. Okay guys, let's quickly do a rough calculation of how many test strips we're expecting there. So we'll just grab that, tear it off, good. Just weigh all of the test strips that he sent, and it looks like we have about 32 grams of test strips in total. And then we'll shift over to the proper little scale, and we'll just weigh let's say 10 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we get about 1.29 grams. So 32 grams divided by 1.29 grams is about 24.8, and then multiply by the 10 shows that he has sent roughly 250-ish test strips, which seems about right. So that's probably accurate enough for us to try and work out what the gold content of each test strip is going to be, assuming we can get enough gold out of this to have a measurable result. Okay, let's move over to the microscope. Okay guys, so as usual when doing these kinds of tests, I like to have a control, which is up here, which is a known ENIG gold plating. So I know that that's a very thin gold plating, and then we're going to compare the control to our sample here, and I'm going to put a drop of the 35% nitric acid on this side here, as well as further down, just to see if there's any difference. So just quickly check my watch, just so we know how much kind of time is progressing. It's about 1 o'clock in the afternoon here, and if I put a little drop right there, and then a drop or two there, and then a few drops over there. I think you guys can see all of that. And now I'm just going to leave this for a few minutes, and then we'll come back and have a look and see if there's any reaction happening here. Okay, and as usual, or as we expected, a few minutes later you can see quite a vigorous reaction happening with our ENIG control sample there. At this point there is absolutely nothing at all happening with the test strip sample, and now I am starting to think that potentially the reason why there is nothing happening with that test strip sample is I don't think that there is any copper underneath the gold on that. It's you can see a few, if I get this into focus for you guys, you can see there are a few scrapes where it has made contact with the obviously the equipment that actually does the measurement, and it looks like it just goes right through to the white plastic. So other than the little splatters that are coming from that mess over there, which is obviously a lot of copper underneath the ENIG, there's absolutely nothing happening with this test strip. So unfortunately I don't think that this process is going to be very productive in terms of figuring out what the gold thickness is. It looks like I'm just going to have to go on ahead and process them and figure it out. Yeah, so that's pretty much it. The downside is I do like to make predictions before I actually do the work, just so we can see what happens, but overall there's not much I can do with these in terms of if the gold is relatively pure and it's just going to sit there and not react, then there's nothing much we can do to actually figure out the thickness of the plating on that. I'm not sure what the manufacturing process is for these test strips, but I'd be interested to know how they deposit the gold onto the plastic without actually going via a copper intermediary. I imagine it's going to be some kind of laser deposition process that's commonly used to put tracks on plastic. Okay guys, so after much internal debate about this, I decided to actually not viralize or burn these test strips, because I was fairly concerned. Like, I only had about 250 of them, and if I stuffed something up or I ended up not being able to separate the gold and plastic after burning it, you know, it would all be kind of wasted, and I wouldn't be able to give anyone, including Andreas, a bit of an answer on this. So I painstakingly peeled every one of these and then used some isopropyl alcohol to clean off all of the adhesive residue. So we've got all of those test strips now nice and clean, and so now it's going to be as simple as covering them in hydrochloric acid and then adding a small amount of nitric acid very slowly. So I don't think the gold coating is going to be very thick, so I'll definitely add the nitric acid almost a drop at a time until the gold's dissolved, and then we'll go from there. Okay guys, so this all happened a bit quicker than I anticipated, but covered the test strips here in some hydrochloric acid, warmed it gently, added a little bit of nitric acid, and it appears to have completely and very quickly dissolved all the gold. We got a nice yellow color there, but I don't think there's actually very much gold in the solution, just based on how quickly the gold just vanished from those test strips. But yeah, we're pretty much ready to go here now, so I'll just quickly make sure this stuff is denoxed, which it's probably will be, because I didn't add much nitric acid to it, so it won't take much denoxing. And then I'm just going to precipitate whatever gold I can with sodium metabisulfite, and then we'll weigh it up and see how it looks. But hey guys, so following evening for me here, and I have got the gold from the Diabetic test strips here washed and ready to weigh up. As you can see, not very much there, but the nice thing with those test strips is because they contain essentially just plastic and gold, you end up getting quite a nice clean drop out of them. So not very much there, and I'm a little bit concerned that we might be getting to the limits of my scale here. I'm not sure that we're quite going to make 0.1 grams, But yeah, we'll get them on the lie detector and we'll see what's what. I think let's let's go this way. That way, yes, I'll zero off the little cap. I was considering adding it just to my my gold lot so far, but the problem with that is that if the scale is unable to measure it, I've essentially have no chance, no second chances there. So we'll add it to the cap, and yeah, just gonna keep your fingers crossed that it's the scale's good enough for this. And make sure I touch the scale a little bit as I'm putting it in to avoid the zero tracking of the scale. Yeah, so as I suspected, 0.000 grams. Unfortunately, I think we're just dealing with too little there. You can clearly see we've got a bit of gold. It does collect quite nicely. I suspect probably what I'd have to do if I was, you guys can probably see it there, what I'd have to do if I were serious about figuring out how much gold that is you would have to melt it and then measure it basically without a nice lab quality scale. You'd have to melt a little bit of gold and then measure the diameter of the little gold sphere that you get, and then with knowing the density of gold you can pretty much work out the how much gold you got out of those 250 test strips. But I'm probably not going to bother going to that extent unless there's a big demand. Suffice to say, 250 of those test strips gave us, you know, less than 0.01 grams, and yeah, nothing much else to say about that. So you know, you've probably got about 50 cents or so worth of gold there from 250 of those test strips. So they're quite easy to process, and because they contain essentially just plastic and gold, you can end up with some nice clean gold. Like this, there's nothing wrong with that. It's just whether it's worth your while chasing it. Anyway, it's a little bit disappointing, but I guess it's a win to some extent that I actually managed to get a little bit of gold like that to have a look at. Anyway, catch you guys later.